Hey guys, today I'll be solving May-June 2017 Variant 2 Paper 2 Physics. Okay, so let's get started. First question, what is the most accurate and precise method to measure the thickness of a coin? So let's take a look at the options we have. A, micrometer screw gauge, and that is the answer, of course. But let's take a look at the rest of the options. B, using a ruler. If we take a look at a coin has negligible thickness. So it can be, we can't find that thickness using a ruler. Ruler has a precision of 1 millimeter, and the thickness of a coin can be less than 1 millimeter. So here a ruler wouldn't be much use. Using a top pan balance, that is for mass specifically. Use the displacement method, this one is for volume. So displacement method is wrong, mass is wrong, and ruler is not of much help to find the thickness of a coin. Okay, so 2. A student determines the average speed of a bubble rising through a liquid at constant speed. Constant speed means 0 acceleration. Okay. When the student starts the stopwatch, the bubble is at point Q. Okay, so let's see point Q. It's right over here. And this is... So this is 18.1, 18.2, this is 18.3. Oh, and P is 25.1, 25.2, 25.3, 25.4, 0.5, 0.6, 0.7. After 2 seconds, the bubble's at Q. Alright. What is the speed of a bubble between P and Q? Okay, let's take a look. So speed is equal to distance over time. And distance is basically the difference between these two measurements. So if we do 25.7 minus 18.3, and this will give us 7.4. Time taken is 2 seconds, so it is 7.4 over 2, which is 3.7. The answer is B. Obviously here the unit is centimeter per second because the unit for distance over here is in centimeters. And the unit for time is seconds. So the unit here is centimeter per second. 3. The diagram shows the speed time graph for a toy car traveling in straight line. When I see speed time graph, I immediately go to the next to the graph and I write slope or gradient is equal to acceleration, and distance is the area under the graph. Okay, let's see what he wants. What is the acceleration of the car during the first 2 seconds, and what is the total distance traveled? Okay, let's see the total distance. Total distance is the area under the graph, as we wrote over here. This shape is a triangle. Now, everyone knows that the area of a triangle is half base times height. Okay, so base here is 5. So it's half times 5, and the height, this is the height, is 4. So the answer is 10. Let's see, the unit over here is in meters, so it's 10 meters. Okay, so it's either A or C. Now let's take a look at the acceleration. Now we can calculate the acceleration using A equals V minus U over T, where V is the final velocity and use the initial velocity. This will give me 4 minus 0, because at 2 seconds it was 4 meters per second, the speed was 4 meters per second, and the time was 2. So the acceleration is 2.0 meter per second squared. This is the unit for acceleration. So the answer is C. 4. In which pair are both quantities measured in newtons? Force and pressure, not pressure. Pressure is measured in pascals or Newton per meter squared or centimeter squared, depending on the givens. Force and weight. Weight is a force. What is right? Weight is measured in newtons, and so is force. Mass is not measured in newtons, neither is pressure. Mass in kilograms or grams. Mass and weight, mass in kilograms or grams, and weight is in newtons. Okay. 5. The masses of a measuring cylinder before and after pouring some liquid into it are shown in the diagram. What is the density of the liquid? So density is equal to mass over volume. This is the mass of an empty cylinder, and this is with the liquid inside it. So to get the mass of the liquid, we subtract the two readings from each other. So 180 minus 80 is equal to 100 grams. And we read the volume of the measuring cylinder. We need to find the scale. So I reckon that the scale goes in 20s. So 20, 120, 140, 160, 180, 200, which is correct. Now, how to find the scale of such things? You count the number of markings between the two numbers. So here we have 1, 2, 3, 4, 5 markings. 1, 2, 3, 4, 5 markings. Okay, if we divide 100 by 5, because the difference between them is 100, it will give me 20. So it is going up in 20s. So this is 140, not 120, as the second up. Okay, so this is 140, this is 120. So the volume is 140. 100 over 140, which will give me 0. It's giving me okay, so it's 100 over 140 gram per centimeter cubed. 6. Spring which obeys Hooke's law. Hooke's law states that force is directly proportional to the extension of a spring. It has an unstretched length of 10 centimeters. A load of 20 is hung from the spring. The new length is 36, so the extension is equal to 36 minus 10, which is 26 centimeters. What is the spring constant K? K is equal to F over X, which equals to 20 over 26. This gives me 0.76923, so on, which can be rounded to 0.77 newtons per centimeter. The answer is B. Okay, let's go on. 7. A car travels forwards on a straight horizontal road. Only the horizontal forces acting on it are shown. So there's a driving force and a resistance, friction. The length of each arrow represents the size of each force. So there's a larger air resistance. So the resultant force is backwards. Fr is here. And there is acceleration backwards. How do these forces affect the motion of the car? The car moves at a constant speed. I don't think so. There is acceleration, but to the back. The car moves backwards, not necessarily. The car slows down. This is correct, as there is acceleration backwards. It's decelerating. The car's forward speed increases. How could the forward speed increase if the resultant force is backwards anyway? So it's the car slows down. car does not move backwards, however. And I can give you a slight example to help you understand this. So remember our skydiver. Okay, he opened his parachute now. So the resultant force is now upwards. This is the air resistance. This is his weight. The skydiver does not go up. Okay, it seems as if he's going up, but he does not go up. He's still moving down due to his weight. He can't go up. He is decelerating. He's slowing down. Okay, and this is exactly the same, but with a car instead. 8. The diagram shows a wooden beam of a weight 20 newtons. The center of mass of the beam is labeled M. There is a pivot at one end of the beam. The beam is kept horizontal by an upward force F. Now, as we can see here, this is a non-uniform rod, as the center of mass is not exactly in the middle. It's after 1.2 meters over 2 meters. Okay, this is a moments question. So here we immediately write moment clockwise equals moment anti-clockwise. Alright? Oh, this might be a uniform, but we don't know the distance here. And this is really irrelevant. But it could be a uniform rod, but it's not mentioned in the question. Okay. There is a pivot at one end of the beam. The beam is kept horizontal by an upward force F. Okay, so there's an upward force here and a downward force here. Now, the moment due to the weight is going clockwise. Okay, and the moment due to this force is anti-clockwise. So, moment, as we know, is equal to F force times perpendicular distance. So moment clockwise is equal to 20, which is the force, times the perpendicular distance, which is 1.2, is equal to this force times its perpendicular distance from the pivot, which is 2. To find the F, we do 20 times 1.2 over 2. So 20 times 1.2 divided 2 is 12. 12 newtons. The answer is A. Okay, 9. A ball of mass 2 kilograms is traveling at a speed of 12 meters per second. It moves towards an object of mass 3 kilograms, which is at rest. The ball hits the object and sticks to it. Now, this is a key word. Which row gives the total momentum and the speed of both objects immediately after the collision? So, here we need to apply the law of conservation of momentum, which is momentum before collision equals momentum after collision. M1 U1 plus M2 U2 is equals to V final speed M1 plus M2. Now what I did here is the rule for sticking to and the law of conservation of momentum. The mass of the first object times its initial velocity plus the mass of the second object times its initial velocity equals to the final velocity of both masses together. And the reason I wrote this is because the objects are stuck together, so their masses become 1. Okay, so I have one of 2 kilograms times 12, and the other one is 3 times 0 equals the final velocity times 3 plus 2, which is 5. So V is equals to 24 over 5. I just did quick algebra. 24 divided 5 is equals to 4.8 meters per second. Oops. 4.8, so it's either A or C. Total momentum in kilogram meter per second. It wants the total momentum of the objects, and that is 4.8 just the total mass, times 5, which equals to 24. The answer is C. Next. An object falls from a height of 5 meters. A resistance can be ignored. Okay. As it hits the ground, the object has 750 joules of kinetic energy. What is its mass? Okay, this one is a trick. We're going to use GPE equals half mv squared. So, sorry. GPE up is equals to the kinetic energy down. Okay, so mgh equals half mv squared, and we can cancel out the m's. So gh is equal to half v squared. Gravity here we're going to use 10, but in the new syllabus of 2023 we use 9.8, unless specified, obviously. So 10 times 5 is equal to half v squared. V squared is equal to 100. V is equal to 10. This is its velocity. V, as we said, is equal to 10. Okay? So now we're given that the kinetic energy is 750. So 750 is equal to the kinetic energy, which is half m, as we found the velocity, 10 squared. So to do a quick algebra, m is equal to half m is equal to 750 divided 100, which is 7.5. M is equal to 15 kilograms. The answer is A. Okay, 11. An electric generator produces an electromotive force EMF of 200 V and produces a current of 3 amperes in a circuit. The generator is driven by an engine with a power of 2.4 kilowatts. What is the efficiency of the generator? Okay, so first of all, as we noticed here, it is in kilowatts. So we need to convert this into watts. So times 1,000 to 2.4 times 1,000 is equal to 2,400. Alright, so this is the power. Okay, and let's find out the the produced power. So we know P is equal to IV, which is equal to 200 times 3, equals 600 watts. To find the efficiency, the percentage efficiency, so it is power in, power out, over power in times 100. And this is equal to 600 over 2,400 times 100, which will give me 25%. The answer is B. Okay, next. The diagram shows athletes training by stretching springs. Each spring has the same stiffness. Which athlete does the most work? Alright. Here it is one spring stretched by 0.60. One spring stretched by 0.80. Obviously, this dude is doing more work than this one, so we cancel A. Two springs stretched by 0.60 or two springs stretched by 0.80. Cancel out this dude. This one is doing much work than C. Alright, so now it's between B or D. Alright, so which person is doing more work? Here, let's name the force in the spring T1. Alright, this dude needed to only do work done against this T1. However, this one is doing work against two T1s, so this one is doing far more work. Okay. Work done is equal to force times parallel distance. Now, all of them are to the same distance, so distance is constant. However, these two are directly proportional, so the more force, the more work done. So the answer is D. 4 different liquids are poured into 4 containers. The diagram shows the depth and density of each liquid. In which liquid is the pressure on its base the greatest? Pressure equals rho GH. And given that they're all on Earth, or they have the same gravity, so just ignore that. Just times these two together to find out the greatest pressure. This one's 31, 24, 39, 32. The answer here is C. Okay. 14. Brownian motion is observed when using a microscope to look at smoke particles. What causes the smoke particles to move at random? Because they're being hit by air particles. Oh, it's the first one. A. Everything else is wrong. This should be memorized. You get asked this question a lot in paper 4, and sometimes it's worth 3 marks. 15. Student blows air through a liquid using a straw. This causes the liquid to evaporate quickly and therefore to cool. Which statement explains why the remaining liquid cools? Slower moving molecules are carried away by air bubbles. This is weird. The air molecules conduct heat from the liquid. No. The air sets up convection currents. No. The molecules will most energy leave the liquid. This is correct. 15 is D. What is meant by the specific latent heat of fusion? This question is cancelled from the 2023 syllabus. You don't need to know what specific latent heat of fusion means. 17. Equal masses of 2 different liquids are put into identical beakers. Liquid 1 is heated for 100 seconds and liquid 2 is heated for 200 seconds by heaters of the same power. Which statement is correct? Okay, let's see. Each beaker of liquid has the same thermal capacity. No. Here it says that there is the same rise in temperature. So if this one takes 200 seconds, this one takes 100 seconds only, then this one has a much lower thermal capacity. Oh, there it is. What I just said. The thermal capacity of liquid 1 is less than the thermal capacity of liquid 2. Liquid 1 is like your nice friend. Okay, when you go out to eat together, they don't eat a lot to become full. This one, however, requires 200 seconds of heating. This is like your friend, your really hungry friend who comes and he devours all the food. And he devours a lot to feel full. Okay. Each beaker of liquid received the same energy. No. This one received more. This beaker, the one with 200 seconds. Liquid 1 receives more energy. No, it's the opposite. Okay. 18. A copper bar and a wooden bar joined. A piece of paper is wrapped tightly around the joint. The bar is heated strongly in the center for a short time and the paper goes brown on one side only. Obviously, we'll go brown on this side. The wooden side. Okay, so the brown side would be the wood side. Wood is an insulator. This is easy. Different waves hit barriers with different sized gaps. The waves will diffract. Which diagram does the greatest spreading occur? For greatest spreading to occur, you need small gap. You need wide wavelength. Okay, so you need large wavelengths, you need a small gap. So we got an option between a gap of 3 centimeters and one of 2 centimeters. So we're going to choose the one with 2 centimeters because it's smaller. You want one with wide wavelength. So the answer here is obviously B. Question 20. The incomplete ray diagram shows two rays of light that have passed from one point on an object through a thin converging lens. Which type of image is formed and on which side of the lens is it formed? Now, as we can see here, these rays will not meet. So they will be formed by the back extensions. Okay, I can't really draw them here. So the image will be formed on the left. And because it's formed by the back extensions and not formed by the real rays, the intersection of the back extension of the rays, not the intersection of the real rays, it is virtual. So the answer here is C. 21. Which diagram shows what happens when a ray of white light passes through a prism? Obviously, each color has a different speed inside of the prism, so A is wrong. When they merge out, they need to go down like this, so C is wrong. D is correct. And no, red does not refract the most, it's violet that refracts the most, so B is wrong. The answer here is D. Okay. Light travels in a vacuum and then enters a glass block. The speed of the light in the glass block is 2.0 times 10 to the power of 8 meters per second. Which statement about the speed of light is correct? The speed in vacuum is 1.5 times the speed in glass. Actually, this is the answer. Let's look at the other options we have. The speed in the glass is the same as the speed in vacuum. Obviously, this is incorrect. The speed in the glass is 1.5 times the speed in the vacuum. We'll get to that. The speed in the glass is 1.0 times 10 to the power of 8 times the speed in vacuum. First of all, the speed of light is less in glass, okay, so this can be correct and this one can't be correct. Then the reason the speed in a vacuum is 1.5 times the speed in the glass is because this is basically the refractive index. Okay, so refractive index equals speed in air or in vacuum over the one in glass. And N is usually like 1.5, 1.6 in this range. A fire alarm is not loud enough and the pitch is too low. An engineer adjusts the alarm so that it produces a louder note on a higher pitch. Okay, so what is the effect on amplitude and frequency? Now, louder note, that means the amplitude is greater. Higher pitch, that means the frequency is greater. So the answer here is A. Student demagnetizes a magnetized steel bar. He places the bar in a solenoid connected to a power supply. He then removes the bar from the solenoid. Which row indicates the most effective way of demagnetizing the bar? Type of power supply needs to be AC. DC is the one where we magnetize. And the reason it has to be AC is because it then mixes up things called domains. So the magnet here, it's made up of tiny little domains. Because it's a magnet, these domains are arranged. You don't really need to know this in O level, but just for the sake of it, you know. Okay, so when we put it through an AC current, okay, so AC current is the alternating current. It goes in one direction, then the other. So this mixes up the domains, makes them mixed up, and therefore it is no longer a magnet. Okay. Speed to remove the bar needs to be really slow. So the answer here is B. A magnet near a coil of wire is attracted to a coil only when there is a current. Why? The coil of wire has its own gravitational field? Of course not. The coil of wire is made from soft iron. This is correct, but there might be but this is not really the reason. The current in the coil of wire creates a magnetic field. Now this one is correct. This is not the reason. This may be correct, but it could also be made of, steel or any magnetizing materials, so it doesn't really need to be soft iron. The current in the coil induces a charge. No, that's not a reason. Okay, so 25 is C. 26. What is wrong with the label diagram of permanent magnet? It's a permanent magnet. It shouldn't be iron, it should be steel. Should be rectangular, not necessarily. The length should be greater than the diameter, not necessarily. The magnet should be made of steel. This one is correct. The N pole and S pole should be reversed, doesn't really matter. You know, you can flip the magnet. Student tests the electrical conduction of 4 metals. Which materials conduct electricity? Aluminium, iron, silver, plastic, no. 27 is A. This is easy. What is the unit of charge? It is Coulomb. An isolated metal sphere is positive charge. It is then brought to another isolated metal sphere that is neutral. What happens to the charges? What happens to the charges is all the negative ones just go towards this positively charged ball. However, protons do not move. Protons just remain. Okay. Some positive charges move, no. Positive charges move, no. No way. Move, no. The positive charges do not move. Some negative charges move to the left, and this one is correct. 29. The answer is D. Okay, last time. Which diagram is the current voltage characteristic graph for a metallic conductor at a constant temperature? Okay, so we need to think about it first here. So the slope here is the R. So resistance is the slope. R is equal to V over I. Right? So it must be directly proportional, right? The slope, it must be directly proportional. That's first of all. R is directly proportional to V, inversely proportional to I, but obviously it's none of our business now. This is FYI. Anyway, because it is at a constant temperature, that means that the resistance is always constant, and therefore it is D. The resistance here is constant. The slope is the resistance, and there's a constant slope here, so the resistance is constant. 4 circuits each contain a 6V battery, a diode, an ammeter, and a lamp. None of the components is faulty. Which current shows a possible ammeter reading? Okay, so it depends on the direction of the diode. So the diode here can pass, go through the ammeter, go through the lamp, back, so it's A. Well, let's check the others. Okay, and it gives a reading. Here it does not give a reading, that's why B is wrong. I mean, passes through the diode, the meter, should give reading. C. It's facing the wrong direction. No current passes. 0 amperes. D. No current passes. Non-negative. It's 0. Student connects a variable potential divider on a circuit. What happens to the reading of the voltmeter as the sliding terminal T is moved from R to S? As it moves from R to S, the resistance increases, right? In parallel, when the resistance increases, the voltage increases. You know, if you want your lamp to glow more brightly, you connect it in parallel to a resistor with really high resistance. Okay. It increases. B. The diagram shows an electric circuit. What is the potential difference across the LDR? Where is the LDR? This is the LDR. Okay, so we know that, okay, we can first of all, let's find so we have the total number of the total current. Okay, so this is the total current, and the total resistance here is equal to 30 ohms. Not that it will matter anyway. Because this is series, the current is always constant. This means that this LDR receives 0.04 ampere, and so does this 10 ohm resistor. Okay. What is the potential difference? So V is equal to I times R, which equals to 0.04 times 20. 0.04 times 20 is 0. Oh, it's 0.4. 0.4, sorry. 0.4 times 20 is 0.4 times 20, 8. 33 is B as well. This one receives 0.4. This one receives 0.4. Okay, so again, this information does not really matter, but this is just for FYI because we're in a series circuit, so the resistance can be just added up together. And because we're in series, it's right here, in series, the I is constant, and the V is divided, okay? So because the I is constant, this arrow here showing the 0.4 ampere, basically saying that this is the current reading in this LDR. We use the formula, V equals IR, this is Ohm's law. 0.4 times 20 is equal to 8 volt. Cancelled. What is the purpose of a relay? To change a large voltage node from small to large, and it's not voltage, it is current. So it's small current to large current. Which device uses a split ring commutator? Now I want you to, so this is commutator split rings, right? So this is a DC motor, okay? In an AC generator, it is slip rings, so don't get confused between them both. Which particle has a negative charge? Obviously, it's an electron, or a beta particle, not an alpha, beta particle. It has 0, -1. This is its charge. Type of nuclear reaction takes place in stars. Which row describes this reaction? Nuclear fusion, not fission. Fusion is involving two small nuclei fusing together, joining together to form a larger nuclei. It's like two small, in our sun, two small hydrogen atoms into one helium nuclei. Into one helium nucleus. Okay. So it is nuclear fusion. The nuclei formed is larger than the original nucleus, and obviously energy is released, not absorbed. Energy is not absorbed. The sun releases energy. So the answer is C. Sample of radioactive isotope is decaying. The nuclei of which atoms will decay first? It is impossible to know because radioactive decay is random. This is correct. It is impossible to know unless the age of material is known. No. We didn't really, in the syllabus, nothing really mentions how to know that a nuclei will decay. We don't know which nuclei will decay first. It's random, completely random and spontaneous. No. All this is just, made up stuff. A sample of radioactive isotope emits particles at a rate of 240 per minute. To 48 hours, the rate of emission has decreased to 15 per minute. Wow, that's little. What is the half-life of the radioactive material? Here it doesn't mention anything about background radiation. So let's see. 240. Let's see how many half-lives it takes to reach 15. Okay, so I'm gonna do it with two methods. First of all is the easy method. So divide it by 2 once, 120, by 2 again, 60, by 2 again, 30, by 2 again, 15. So it took me 1, 2, 3, 4 half-lives. 4 half-lives in 48 hours. So 48 divided by 4 gives me 12 hours, and this is the half-life. This is like easy method, you know. But there's also a mathematical way of doing this. Okay, so let's see. We can do 240 divided by 15. The original reading and the reading left will give me 16. Now write 16 in the power of 2, which gives me 2 to the power of 4. This power indicates the number of half-lives. Okay? Because it's 4, we'll do 48 divided by 4, same step as the last time, and it will be 12 hours. And this is it. The end. Hope you enjoyed this video. Hope that it benefited you, and yeah, that's it. Recommend this channel to your friends, and I'll be uploading more at Just Another Student. Thank you.